If someone told you ChatGPT was, deep down, just arithmetic, would you believe them? By the end of this course, you will. So, where do we begin? At the very bottom, with numbers. Think of numbers as a ladder. The bottom rung is counting. 1 apple, 2 apples, the naturals. Add the idea of debt, and you get negatives, the integers. Slice things into parts, and you get fractions, the rationals. And fill in every gap on the line, pi the square root of 2, and you have the reals. Machine learning lives on that top rung because a weight can be any value at all, like minus 0.37. Once numbers can be anything, we need a shorthand for combining lots of them. That shorthand is algebra. We give a number a name, call it W for weight, X for input, and write rules that hold no matter the value. And when we add up many terms, we do not write plus 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 1,000 times. We write one capital sigma. Sigma means sum. Sigma from I equals 1 to n of Wi times X. I says, walk through every input, multiply each by its weight, and add them all into a single number. That one expression is a neuron. Its cousin capital Pi multiplies instead of adds, and exponents and logs are just the same move in reverse. Log turns multiplication into addition, which is why losses are written in logs. It keeps the numbers tame. Here is the ML tie-in, and it is the whole course in one breath. A linear model is exactly that sigma, a weighted sum of inputs. Logistic regression wraps a log around it. Training is nothing but nudging those bows so one final number, the loss, gets smaller. Numbers in, numbers out, arithmetic the whole way down. Here is the whole thing in one short file. We will build a tiny linear neuron by hand, 3 inputs, 3 weights, compute its output as a literal weighted sum, and watch the same number appear in our manual loop, in NumPy's dot product, and on a bar chart. First we seed a generator so you get the exact same numbers I do, and we write down 3 inputs and 3 weights as plain arrays. Then we compute the weighted sum the slow honest way, a Python loop adding w times x term by term, so you can see the sigma happen. Next we compute the identical value with NumPy's dot, proving the loop and the vectorized one-liner agree to the last decimal. We add a tiny squared error loss against a target, just one number measuring wrongness, and take its log to show logs keep magnitudes friendly. Finally, we print everything and draw a bar chart of each term wi times xi with the total annotated. The figure and the terminal say the same thing. Numbers are the alphabet. This weighted sum is our first word. Next episode we ask, what happens when that sum becomes a shape you can draw, functions and the geometry of a model.